Hi friends, in engineering physics we are going to see about justify laser optical methods for charging required transport studies in low temperature fuel cell. Abstract. The behavior of proton exchange member fuel cells strongly depends on the operational temperature in mobile application. For instance, in fuel cell electric vehicles stack are often subjected to temperature as low as minus 20 degrees Celsius, especially during cold start period and to temperature up to 120 degrees Celsius during regular operation. Therefore, it is important to understand the impact of temperature on the performance and degradation of hydrogen fuel cell to ensure a stable system operation. To get a comprehensive understanding of the temperature effects in PEMFCS, this manuscript addresses and summarized in situ and executive investigation of fuel cell operated at different temperatures. Laser. A laser is a device that emits light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. The word laser is an acronym for light amplification by stimulated emission of radiation. This first laser was built in 1960 by Theodore H. Hyman at Conscious Research Laboratories, based on the theoretical works by Charles Horton and Arthur Leonard Chandler. This is one type of another razor. Red, a red in color, up to 660 at 600 and 365 nanometer. In green, 532 and 520 nanometer, and blue violet 445 and 405 nanometer lasers. Lasers are used in optical disc device, laser printers, barcode scanners, DNA sequence instrument, fiber optic semiconducting chips manufacturing, and free space optical communication, laser surgeries and skin treatment, cutting and welding material, military and law enforcement device for making targets and measuring range and speed, and in laser lightning displays for entertainment, semiconductor lasers in the blue to near UV have also been used in place of light emitting diodes to excite fluorescence as a white light source. This permits a much smaller emitting area due to the much greater radiance of a light and avoid the droop suffered by LEDs such as device are already used in some car headlamp. Laser diode. A laser diode is a semiconductor device similar to a light emitting diode, in which a diode pumped directly with electric current can create lasing conduction at the diode's junction. Semiconductor device similar to a light emitting diode, in which a diode pumped directly with electrical current can create lasing condition at the diode junction. Fuel cells. Now we are going to see about fuel cells. A fuel cell is a electrochemical cells that convert the chemical energy of a fuel and an oxidizing agent into electricity through a pair of redox reaction. Fuel cells are different from most batteries in requiring a continuous source of fuels and oxygen. to sustain the chemical reaction, whereas in a battery, the chemical energy usually comes from metals and their ions are oxidized that are commonly already present in the battery except in low batteries. Fuel cells can produce electricity continuously for as long as fuels and oxygens are supplied. Fuel cells are used for primary and backup memory for commercial, industrial, and residential buildings and in remote or inaccessible areas. They are also used to power fuel cell vehicles including forklifts, automobiles, buses, boats, motorcycles, and submarines. There are many types of fuel cells, but they all consist of an anode, a cathode, and an electrolyte that allows ions, often positively charged hydrogen ions, to move between the two sides of the fuel cells. And the anode, a catalyst, causes the fuel to understand oxidizing agent that generates ions and electrons. The ions move from the anode to the cathode through the electrolyte. At the same time, electrons flow from the anode to the cathode through an external circuit, producing direct current electricity. At the cathode, another catalyst causes ions, electrons, and oxygen to react, forming water and possibilities and other products. Fuel cells are classified by the type of electrolyte they use and by the difference in startup time ranging from 1 second for proton exchange member fuel cells to 10 minutes for solid oxide fuel cells. A related technology is flow batteries, in which the fuel can be regenerated by recharging. Individual cells produce relatively small electrical potential, about 0.7 volt. So cells are structured or placed in areas to create sufficient voltage to meet an application's requirements. In addition to electricity, fuel cells produce water, heat, and depending on the fuel source, a very small amount of nitrogen, oxidizing ox- nit- nitrogen dioxides, and other emissions. The energy efficiency of a fuel cell is generally between 40 and 60 percentage. However, if waste heat is captured in an cogeneration schemes, efficiencies of up to 85 percentage can be obtained. Conclusion. In conclusion, we reviewed the impact of temperature on the performance and the durability of PEM FCS. In the first part, in situ measurement methods to monitor the temperature distributions along the flow channels and perpendicular to the member were addresses. Monitoring heterogeneity in the temperature descriptions can be help to gain insights on the local current densities, relative humidification, and water conservation between GDL and BPP. Here, in understanding the mechanisms that determine local temperature are incredible for stable and durable PEMFCS operations. Thank you.